I want to determine the lateral extent of some bright anomalies that can be seen on this inline in the 3D view. I can use a probe to help focus on the volume of interest. A flat pizza box style is good for looking at stratigraphic intervals such as this one. In the 3D tab, the Use Probe option displays all the volume samples as individual points within the probe, giving it a solid cuboid appearance. Turning off the inline allows me to focus on the probe. I can now make individual samples transparent based on a value using the interactive visualization slider. I will remove all the positive values, leaving just the brightest negatives. Whoa, look at those bodies appear. As well as adjusting opacity for a range of values, I can adjust the class opacity for all the values to see a bit more of the structure underneath the surface of these bodies. Rotating the view shows some channel-like features. The probe opacity editor is very interactive, but it doesn't allow me to permanently capture these samples or connected bodies. There are a couple of other processes that might help. Volume maths can be used to identify all the brightest negative values. Provide the workflow with a suitable name, then add the volume. The formula compares each sample to a cutoff of -49,000, then outputs the sample to a new volume if valid, and outputs a missing value if not. I check that the output volume has the same color bar as the original volume, then switch the volumes in the display. The results has the same shape but is more blocky and noisy. This is because the interactive slider allows me to finely adjust the cutoff, and the results are smoothed by Insight. Another process to create visual bodies is body detection. Select the process from the list and give it a suitable name. Select the volume and the probe, and define the same cutoff as used in volume maths, below -49,000. The bodies are detected and can be seen when the current volume maths body is hidden from view. The bodies look nice and smooth because the process looks for connectivity and connects the samples into smooth objects. Tiny disconnected samples can be removed by increasing the minimum body size allowed. Bodies can be made bigger by changing the connection rule between adjacent samples. Face-to-face connections are less frequent than edge-to-edge or vertex. Selecting vertex connections give the largest connected bodies. The process gives a calculation of volume, which in this view is in meters squared seconds, due to the display being in two-way time. A display in TVDSS will return meters or feet cubed. The results of volume maths or body detection can be exported to disk as a regular WO or seg-y volume for use in other projects. For a final trick, I will return to the original volume display that has been opacity rendered. Switching to a flattened domain based on the top of the stratigraphic interval, the display becomes even clearer as any structural effect has now been removed, leaving only the stratigraphic response. If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight.